The top 5 electrical formulas every electrician has to know. If you are an electrician, there are 5 formulas you simply can't live without. Forgetting even one could cost you time, money, and maybe even your safety. Today I am going to break down the top 5 electrical formulas every electrician must know. And by the end of this video, you will be able to apply them to the real-world jobs instantly. If you are new here, my name is Yapsra, and on this channel I make electrical science simple and practical for electricians and electrical hobbyists. Subscribe and turn on the bell notification so you don't miss more tips like this. Let's start with the king of all electrical formulas, Ohm's law. This one is not negotiable. Ohm's law is one of the most important principles in electrical work. It tells us how voltage, current, and resistance are related in any electrical circuit. The formula is V is equals to I multiplied by R, where V is the voltage in volts, that is the push that moves electrons through the circuit. I is the current in amperes, the amount of electron flow, and R is the resistance in ohms. That means how much the circuit resists the flow of current. You can arrange the formula to find any of the 3 values. That is, I is equals to V divided by R, where current equals voltage divided by resistance. Resistance equals to voltage divided by current. If a 12-volt battery is connected to a resistor of 6 ohms, then the current will be 12 divided by 6, which is equals to 2 amps. Why this formula matters? Ohm's law helps electricians to design circuits, choose wire sizes, and select fuses and troubleshoot. If you know any 2 values, voltage, current, or resistance, you can calculate the third instantly. In short, more voltage means more current, more resistance means less current. That means it's the fundamental rule that keeps electrical system safe and predictable. The second formula is the power equation, which is very important because power matters. Electrical power is the rate at which electrical energy is converted into work, heat, or light in a circuit. In simple terms, it tells you how much work electricity is doing per second, whether it is lighting a bulb, running a motor, or heating a bread machine. The basic formula is P is equals to V multiplied by I, where P is the power in watts, that is the amount of energy used per second. V is the voltage in volts, that is the push that derives current, and I the current in amperes, that is the flow of electrons. If you have a 240 volt supply and a current of 5 ampere, then the power will be 240 volt multiplied by 5 ampere, which is equal to 1200 watts or 1.2 kilowatts. From Ohm's law, which is V is equals to I times R, we can also express power as P is equals to I squared times R, where power from current and resistance. In the second one, P is equals to V squared divided by I, R, which is power from voltage and resistance. Why this equation matters? Power formula helps electricians size equipment, calculate energy consumption, choose safe cable size, and avoid overheating. It's also how we figure out the electricity bills. Power over time gives energy in kilowatts hours. In short, more voltage or more current gives more power, and it is the key link between electrical energy and the real world work it performs. The third one helps you figure out electricity cost and usage, electrical energy, which is the total amount of work done or heat produced by electricity over a period of time. It tells us how much electricity is actually used, and it is what utility company charges you for. The basic formula is E is equals to P times T, where E is the energy in joules or watt hour, P is the power in watts, which is the rate of energy use, and T is the time in second or hours. A 100 watt bulb running for 10 hours gives the energy of 100 watt multiplied by 10 hours, which is equals to 1000 watt hour or 1 kilowatt hour. If energy cost is $0.15 per kilowatt hour, that is 50 cents to run. Since power is equals to voltage multiplied by current, we can also write E is equals to V times I times T when voltage and current are constant. The electricians use it to estimate generator or battery runtime. Engineers use it to size solar panels, UPS systems, or inverters, and customers use it to calculate the electricity bills. 1 kilowatt hour is 1000 watt used for 1 hour. In short, power tells you how fast energy is used, but energy tells you how much is used over the time. The formula connects the rate of electricity consumption to the total cost and capacity needed. Now let's get a bit more technical, the resistivity formula. Electrical resistivity is a property of material that measures how strongly it resists the flow of electric current. It is not about the size of shape of a conductor, it is about the material itself. That is, the formula rho is equals to R multiplied by A divided by L, where rho is the resistivity in ohms meter, R is the resistance in ohms, and A is the cross-sectional area of the conductor in square meter, and L is the length of the conductor in meter. Meaning, if a material has high resistivity like rubber, it is a poor conductor. If it has a low resistivity like copper or silver, it is a good conductor. If a wire has a resistance of 0.5 ohm and a length of 2 meter and a cross-sectional area of 1 millimeter square, which is 1 multiplied by 10 raised to negative 6 meter square, resistivity of 0.5 multiplied by 1 times 10 raised to negative 6, this is equal to 2.5 times 10 raised to negative 7 ohm meter, which is typical for copper. Resistivity helps electrician and engineers choose the right material for cables, heating elements, and resistors. It also explains why wires get hot. Longer or thinner wires have more resistance. So material with low resistivity are preferred for efficiency. If you double the length of the copper wire, the resistance doubles. If you increase its thickness, the resistance drops. In short, resistivity is the DNA of material electrical behavior. It tells you how well it can carry electricity no matter its size. Finally, the voltage drop formula. It's critical for long cable runs. Voltage drop is a reduction in voltage as electric current flows through a conductor. It happens because conductors have resistance, and some electrical energy is lost as heat along the way. So the basic formula is V, or voltage drop, is equals to I multiplied by R, where V drop is the voltage drop in volts, I is the current in amperes, and R is the total resistance of the conductor in ohms. For conductors, R can be calculated as R is equals to rho multiplied by L over A, where rho is the resistivity of conductor material, which is measured in ohm meter. L is the length of the conductor, which is measured in meter, and A is the cross-sectional area, which is measured in meter square. For single-phase circuits, the simplified formula will be VD, or voltage drop, is equals to 2 multiplied by L multiplied by I multiplied by R divided by 100, where L is the length in meters, I is the current, R is the resistance per meter. The coefficient 2 is used because there are two wires used in the single-phase system, which is phase or line and neutral. Example, if you run a 20-meter cable carrying 10 ampere with a resistance of 0.02 ohm per meter, the voltage drop will be 2 multiplied by 20 multiplied by 10 multiplied by 0.02, which is 8 V. Voltage drop will be 8 volts, which is equal to 10 multiplied by 0.2, which is 2 volts lost along the wire. Why voltage drop matters? Because too much voltage drop can make equipment run inefficiently or fail. Electrical codes often limit voltage drop to around 3% for lighting and 5% for power circuits. Electricians use the formula to size wires correctly. That means longer runs or higher current need thicker conductors to keep voltage drop low. In short, voltage drop is like water pressure loss in a long pipe. The farther the electricity travels through the resistance, the more push it loses before reaching the load. Let's finalize the general formulas. The first one, V is equals to I multiplied by R, which is the Ohm's law. The second, P is equals to V times I, which is the power formula. The third, E is equals to P times T, which is the energy formula. The fourth one, R is equals to rho times L over A, which is the resistivity formula. And the fifth one is VD is equals to 2 multiplied by L multiplied by I multiplied by R divided by 1000, which is a voltage drop. If you keep this in your head, you can solve 80% of the calculation you will ever need in the field. If this helped you, give it a like, so more electrician can see it. Drop a comment below telling me which formula you use the most, or if you want me to make a deep dive video on it. If you haven't yet, subscribe for more practical electrical tips every week. Stay safe out there, and I will see you in the next video.